Hi everyone, welcome to this tutorial. In this tutorial, we are going to learn about the structure design of an office building, the one you're seeing in this on the screen right now. So this is going to be an interesting video whereby we shall learn about the design of steel structures, design of concrete structures. Why would I say so? As you can see in this picture, we have some steel facade. You can see this steel slanting column. You can see this cladding around the roof. So we are going to support it using steel trusses. But then the main frame will be concrete, whereby we shall have concrete columns, concrete beams, and concrete slabs. This is another view of the building we are going to look at. So basically we are going to use two softwares, that is Revit. Okay, not two softwares, but mainly we are going to be using Revit for drafting and detailing. Then we shall use Etabs for design of RC and steel frames. So without wasting time, let's get into the tutorial. So right now I'm going to open my Revit. Of course, I'm using Revit 2025, but it can still apply to any version of Revit, let's say 18, 17, 18, 19, 20, 21, up to 25. Doesn't matter the version you're using, because literally there's nothing that changes much. So, uh, this being my home screen, of course, these are some of the recent projects I've done. Normally, you're supposed to come to pen. Actually, I want to keep this tutorial very basic, whereby I'm going to be using the native Revit templates. I won't be loading in my personal templates. I want us to see how we can use the native Revit templates. Then later on, we see how to personalize those templates such that any future projects, we can easily use our own personal templates with our personal settings. So I'm going to come to new. Now here I have two options. I can use actually three options. I can use Imperial multidiscipline template or metric multidiscipline template. So I prefer using the metric multidiscipline template. Then I'm supposed to say okay. Alternatively, now this metric multidiscipline, it has all disciplines, let's say architectural discipline, structural, plumbing, electrical, mechanical, and so on and so forth. Um, then in case you want to be so specific, if instead of using this metric multidiscipline, this metric library, okay, sorry, browse, yeah, under here, you see we have a commercial template, structure analysis. So in case you're doing a structural structural design project, you can either choose structural analysis default or this one, the structural analysis default metric template. So let's just choose, I'll just go with the metric multidiscipline. So I'll say okay. So I'll give it a few seconds to load. Don't forget to like and subscribe, because I'm going to be making important videos like this, which are actually so helpful. So when the template opens, then it's time now to view uh, what the architect gave us. Because normally the process is that an architect will share with you PDFs and DWG, that is the AutoCAD files. So you use those AutoCAD files, create your own structure layouts. Then you can export that model into Etabs, assign loads, analyze design, if everything's passing, export back Etabs, then import it in. So export back to Revit, import it in Revit, then do the detailing. So according to this office building, let me first show you. It has the ground floor. It will have a first floor, second, and a roof. So let me try to open one of the PWGs. So I'll come to insert. It's better you use link card. The advantage of using link card over import card is that when you use link card, you can always update the DWG in case there is a change from the architect or any other discipline. Let's say maybe the plumbing, in case they change a duct position. So you use the link card to update it. Then you can also adjust your structure design accordingly. So I'll come to link card. Then I'll definitely browse where I saved my file. Okay, link card, this computer, and here I saved it under YouTube, files, office building, DWGs. So I have office elevation, ground floor. So I'm first going to import the ground floor. Okay, let me start with the section through, section through the building. Anyway, let me start with the ground floor. I'll say open. Close. Oh yes. Now my DWG of the ground floor has been imported. So I'll come to still link cards. Space local disk D, YouTube. So I'll try click on this section and pin it by pressing UP. Then okay. Now here you realize that I can't select these linked card files simply because they are pinned, and sometimes under your selection settings you might have set it not to select pinned objects. So to be able to select this, because I wanted to move this section beside the ground floor for easy visibility. So in case you can't select it, come to select, make sure that select pinned elements is checked. So now you can see I'm able to select it. Then to unpin it, I'll click on this icon here or press UP. Then I can drag it up to let's say down here. Okay, let me put it on the sides. I'll click on this. Okay. Now, let's just take a quick study. But I don't like these colors. So what I'm going to do, I want it to be black and white. I'll say override category, projection lines, put it to black, apply, or self-healing. Okay. Come back, insert link card. Under these settings, on colors, I'll set it to black and white, bring section 5. They will definitely come here. Press UP to unpin, drag it. Drag it up here. So now when you try to zoom in into this section, you see we have the ground floor at 0, 0. We have the first floor at 4,000 millimeters, that is 4 meters. We have the second floor at 8,000 meters. And we have the roof at 12,000 millimeters. So meaning we need to, our next step right now is to create how many levels the ground floor, create the first, second, and third, plus the roof. So that was the purpose of importing this section at this moment. Okay, now to set the levels, we need to scroll down and go to under project browser here. Let's go to elevations. Expand it in case it is not showing the levels. Open any elevation of your choice. So right now we have these levels. So create a new level, click on an existing level, click on this button or shortcut is quite similar, or without any command, press LL to create a new level. So I'll create this. I'll create one more and this. Then from our section, we saw that we had level L1, ground floor. We had level 2, first floor, and it was at 4 meters. We had level 3, second was at 8 meters. And we had level 4, roof level was at 12 meters. Let me go back to this to confirm. Yeah. And then you see we have this parapet wall, which is 1.5 meters. So I'll go back to my north elevation. For the meantime, let me first delete this. And then we need to create the foundation for this structure. So I'll create a level below ground floor. I'll call it L00 foundation level. So I'll put it at like minus 1,500. Okay, so now when I try to come to this, so I need now to make all these levels structural levels. So to do that, just select all of them like this. Change the scope to grids and levels, scope box. Then elevation, leave it at that. Come to where we have identity data here. Make sure it is all the structural option is checked. Then click apply. Then come to view. You click plan views, structure plan. Click on shift, select all of them, say okay. Come back to views, floor plan, shift, select all of them, say okay. So now these levels are now visible. So right now you can see they are visible under architecture. But then remember, this is a multi-discipline template, so we want these levels to be visible under structural template. So I added as a structural flow. So what I will do, I'm going to minimize this. Then I'll scroll down where I have structural. Then I'll come to structure plans and expand it. So we have structure plan L1, L2 foundation. Of course, L1 is ground floor. So you can always rename it from here, even ground level. L2 is first floor. L3 second roof level, which is now okay. So I'll open this now after having set all the levels. So now it's time to start understanding our building. Now, if you look at this building, it has a ground floor, whereby here we have a reception. This is the porcelain tile finish. Then besides the reception, we have stairs. Then we also have a lift shaft or elevator in between. Then here we have an office space. This side we have washrooms. So now for us to sketch a proper structural layout, we need also look at other levels such as that we are able to see how columns and beams are likely to affect each and every floor level. Now, so meaning we need also import the second floor and the third floor. So I'll come to now click on first floor here. Come to insert link card. By the way, I'll leave all these DWGs for download in the description of the video. So endeavor to check it out for practice. So I'll select first floor. Make sure it is under colors, it is black and white. Say open, close. So in case it is not visible, expand the architectural level. Come to L2. Click on this first close called unnecessary open windows. First open L1. Select this, open L2. Right click and say select previous. Right click and hide. So now we are able to see the second floor. Now the second floor is almost typical to the ground, whereby after having used the stairs and the elevator, you just come onto this circulation, which leads you into another office area, and the washrooms are exactly above the ones on the ground floor. So I'll also first come back to architectural L3 and I import the second floor. Open, close. Yeah, it will also come. So yeah, we are being lucky that the architect had suggested some column positions. So we shall try to adapt this and see if it passes, because some columns were made to pass through spaces for artistic reasons. So I'll scroll on to the structure plans. Let's say first floor. Then I try to come to this. You see this reveal hidden elements. Why we are not able to see the imported DWGs on this level? It's because they are hidden. So what you do, click on this bulb icon or review hidden elements icon. Right click on this. And hide the view by category. If it fails, click on this and hide the view. So these were hidden by filters. Let's leave it at that. We shall first go back to the architectural levels. Second floor. Now, our next step is to create the grids. Now, for us to be able to create the grids, open any of the levels. Let's say it is, press GR for grid lines, or alternatively come under architecture grid. Shortcut is GR. So select this, pick lines, click on grid 1, type in 1, ensure that it is 1, click on 2, 3, 4, 5. So basically we're tracing the architectural grids. So come to this one, press A, change it to A, B, C, D. There we go. Now, the next step is to draw columns. Now, to draw the columns, let's come to architecture. So the structure, select this structure column. Shortcut is CL. So come to this. Let's take any size. Remember, we haven't done any preliminary sizing, so we're just going to assume any column size. So we shall later on adjust it accordingly. So I'll select this edge type, rename it, I'll call it C 300 by 300. Press OK. So I'll change this to 300. So my column comes. I'll first try to place it anywhere. Then I'll go to 3D. I will locate this column at this point. Make sure this is fine. So when I select this column, I will change the base level to ground floor, then the top level to first floor. So I'll go back to my L1 architecture. So here now I'm able to see the column. I'll first change this to thin lines for proper visibility. But later on during detailing, I'll need to change it back to thick lines. So I'll click on this column, right click and say override by category, surface cut patterns and cut patterns are all a solid fill. So I'll click on copy, select the center, place it one here, place another one here, another one here. I'm basically following the architectural columns, how they were placed. Click on align to align this. So now you realize I can't have a column here because it is at the entrance through a reception. So I'll first keep that grid. I come to this and I come to this. So lastly, I'll come to this grid here. This one here. This one here. This one. And this. So I'm going to first delete this section view. So I'll click, I'll also delete the first column we made because it's no longer needed. So I'll try to align these columns to ensure that they are perfectly along the grid lines. So I click on align and ensure align multiple is checked. Go to the next green. Go to the next one. Oops, sorry. Align shortcut is AL. Go to the next one. Go to the vertical ones. Okay, having aligned all the columns, so I'll click on one of the columns, press S8, select all of them, click on copy to clipboard or Control C, come to paste selected levels. I'm currently on the ground floor, so I'm pasting on the first and second. So when I open one of the structure plans, let's select the first floor, I should be able to see the columns. Also right click on one, override by category, and the cut patterns, make it a black solid fill. Okay, there you go. Same, the second floor, override by category, make it a solid fill. Okay, the ground floor, override category, make it a solid fill. Okay. So now coming to the one of the first floor levels, I'm going to click on one of the grids, edit type, check this end one default, put the bubble such that it is visible on all sides. I'll change the scale to 1 to 50. Then I'm going to start sketching the beams. Now I'll sketch the beams. Let's come to structure, beam. Shortcut is BM, press BM on your keyboard. I'll look for something concrete here. Currently, I don't have any concrete beam loaded. So to load one, I'll come to load family, metric libraries, I'll go to US, scroll down to structural framing, concrete beam rectangular design. I'll say okay. So it loads. I'll come to edit type, duplicate. I'll call it beam 250 by 500. Remember, all these sizes are just basic sizes. I'm going to do the real preliminary sizing such as that we have. Then later on do the actual sizing to have the real sizes that are sufficient enough to support that structure. Say okay. So this is 250 by 500. So I can use this option of on grids, but then some grids are my grids are going through, so I may need to do a lot of trimming. So what I prefer doing is basically coming to the center of a column, drag up the last column. Since if my beam is continuous, I'll also do the same here. I'll do the same here. I'll do the same here. And I'll press escape once. When you press escape once, the command remains in, but it detaches from your previous selection. So you don't need to go back to architecture to structure, then be selecting the beam option. But then there's one thing I want you to take note of. I was just sketching randomly. When you with your beam command loaded, when you come under properties here, okay, let me get the command again, beam. Under geometric positioning, you can see I have this Z or Z description reading top. So when you click on this, it has three options, actually four. There is origin, center, and bottom. So currently it is on top. So we shall see the difference and how to go about it with time. That was just a by the way. So I'll proceed by sketching my beams. My beams. I'll change to this. Then I have this. And I have this. Now this beam is supposed to reach up to the end. So I'll get extend, click on the grid line, then on the beam to extend it. So I'll click on one of the beams, press SA, copy to clipboard. Right now I'm on the first floor. Select LED levels. I'm going to paste them on the second and the roof. So I'll go to 3D to see what I have. Okay, almost there. I'm first going to hide these DWGs. Click on one, right click, hide category. Doesn't work. I guess I have to select it independently. Now we can see that our building is starting to take shape. Maybe let me change this to shaded. You can see my beams and columns. So from here, you can see what is lacking is the foundation. Okay, the starter columns and the footings. So to have that, I'm going to open the ground floor. I'll click on one of the beam files. I'll say select all instances visible in view. Then I'll select on the base level. I'll change it to foundation. I'll change it to foundation level. Then you see now the columns have extended a bit. Now to put the footings, I'll come to structure, isolated. Then I'll say edit type, duplicate, call it F1, say OK. Continue the dimensions to 1500. I'll leave the foundation thickness to 450. I'll say OK. I'll come to, I can independently be putting on each column, but that is a wastage of time. So it's better you select this at columns, this option of at columns. Then drag and select all the columns. Say OK. It will bring this warning. None of the elements created are visible on structure plan L1. You may want to check the active views. Doesn't matter. What it does is that it puts the footings on the lowest level. So I'll come to 3D. Now you can see I have my footings. Then I'll need to put a ground beam around here. Now, to do that, I'll open the ground floor, actually the first floor. Click on one of the beams, select all instances visible in view, copy to clipboard, come to ground level. You say paste current view. I'll pass it save. First, going to hide these. Select the pasted column beams. Select all instances visible in the view. I'm going to duplicate. Now these are ground beams. I'll call them ground beams. So I'll change the depth to 300 and the B to 200. Of course, we shall design for this and see if they are sufficient enough. So going back to my 3D, there we go. Now I'm going to first go back to the architectural plans. I'll open L1 architecture, which is the ground floor. I now need to sketch this lift, the shear walls for the elevator or lift shaft. So to do that, I'm going to come to structure, wall, structure, wall, structure. I'll come and measure this, get this, measure here, measure here. So these walls are 200. So right now, we do not know if they are strong enough or weak. But for the meantime, we're going to take the same thickness of the walls. So the design will tell us if they are sufficient. So a quick reminder, what I'm doing now, or what we are doing now, is coming up with a structural layout, a model that is ready for exporting into Etabs for design and loading. So I'll come to structure, wall structure. Click on this arrow. I'll look for retaining 300mm concrete. So I'll say edit, duplicate. I'll call it shear wall. In fact, I'll call it 200 mm shear wall. Come to edit here, change the thickness to 200. I'll say okay. So I'll try to trace this wall. Okay, before sketching, I'll look at the base constraint and the top constraint. So the base constraint will read the foundation level. Base offset is 0. Top constraint to go up to the second floor. In fact, it will go up to the roof level. Because remember, we need that volume above the lift shaft for the lift to do what? For the movement of the lift. So I'll click here, up to this point here, up to this point. Now here we have a lift or an opening to the wall. So it's better actually you close it, then you create an opening automatically. So I'll first close this. I'll click on align to align a few things. Okay, here we go. We have our core. So if I want to go back to 3D, you can see we clearly have our concrete shear wall or core at this point. So if I'm check back on this this 3D, you see we have this cladding around the building. Let me open another picture. Okay, here it is. Okay, then we have also this cladding acting as an entrance canopy at the entrance here. Of course, you can see this is the reception desk, reception chairs. So these ones are going to be supported by use of steel trusses or steel structure. So we shall model that in Etabs, and also this retaining wall facade will be done in Etabs, whereby we shall design these sections which will be used for supporting the glass around the building. So meaning here what we are going to do, I'm going to first select actually all these beams on the roof level. I'm pressing Ctrl to select, add the selection. So with all the beams selected, I'll come to edit, duplicate. I'll call this ring beam 200 by 300. I'll press enter, make the 300, and also make this 200. Now, for the stairs, we shall also model them in Etabs. So although the stair slab can also be modeled from Revit, actually, which is even much easier. So, okay, let's look at how we are going to model the stairs. Now, to model the stair slab that can be taken into Etabs analysis, we need to first know or cut a section through the existing architectural stairs and see how they are moving. Because as you can see, we have a total of 26 risers at 148.1 millimeters. Because remember, our flat floor height is 4 meters. So let's get a calculator and see. They are saying 26 times 148.1 should be able to give us 4 meters or close to 4 meters. So I'm seeing it is around 3.850 minus 4,000. So actually they're supposed to be 27 risers, not 26. So if I'm to go by 27, okay, let me see. 4 meters divided by 150. So that gives us 27 risers at 150. So that is exactly what we are going to do now. So if we have 27, okay, let us see. We need to divide this distance into 4, whereby we shall have we shall rise by 10. Here we shall have 10 risers. So let's see, if we have 10 risers, it will be 10 times 150. So meaning this level, this from the first step where the first landing starts, this first landing here, it should be a difference of 1.5 meters. Then there to go flat. So when it becomes flat, then we shall now rise again by how many? 11, 16, that is 5. Those are 5 risers. So we shall have now 5 times 150. So that is 750 plus 1.5. So that is 2,250. Then we shall rise again by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 risers. So this is plus 1,500. So it's 370. Meaning that doesn't work. Yeah, that doesn't work. So what does it mean? It means we need to divide this distance into 3. So let us see. If we have, if we rise by 2 meters, sorry, 1.8 both sides. So that will be, okay, by 1.7, 1,700 times 2. We shall have our total height will be 3.4. So we shall be left with 600. So then 600 divided by 150. So we shall need 4 steps in the middle. But 1,700 divided by 150. So we shall have 11 risers. 11 here. Okay, 11 here. 4 here. 11 here. So giving us 22 plus 4. Those are 26. Yeah, I think that works. So now what we are going to do, I'm going to come to structure. I come to floor, floor structure. I'll come to edit type, duplicate. I'll call it stair slab. Then I'll give it a basic thickness of around one. Okay, let me give it 250, maybe 200. 200 is okay, but I will show you how to come up with a thickness of stairs during the design. So I'm first going to give it a material of concrete. Click on one, press C. I'll give this concrete casting settle. Okay. Okay. Now I'll click on the rectangle. Click on this first arrow. I'll go up to this point here. I'll press finish. Then I'll come again, click, create similar. I'll click on this point here. I'll drag. I'll first turn on the lines. I'll come this point. I will finish. Create similar up to this point. Finish. Create similar. Come to this point. Finish. Create similar up to this point. Finish. Now let us try to adjust them. Now to adjust them very well, I'm going to first cut a section here, cut a section here, cut a section there. So I'll come to section, cut one like this, drag this view extent to be around here, right click to open the section, go to view, there we go. So we have our stair currently flat, so our stair slab. So I'll click on modify, come to 3D, I'll click on this point, I'll put in 1700. I'll click on this one, I'll also put 1700. I'll press it. Now we can see our stair slab. Then I'll click on a free space. I'll come back to my L1 architecture. I'll click on this. Then I'll offset it from the ground to be at 1700. So if I go back to 3D, now I can clearly see my first landing. Then to get the other flight, so remember the other one was 1700 times that was 6,400. So meaning I need this price by 600. So what I'm going to do, I'm going to select it, of course offset it by 1700 at this point. First click on edit, ensure that they are in line. Finish. Then modify points. So I'm going to add 600 to this. So I'll say this plus 600. I'll put an equal sign behind here. And so this is 2300. So this is 2300. There we go. So I'll get the next landing. I'll put it at an offset of 2300. See how it's coming. Then it means I'm just left with this. Also offset it at 2300. But then it needs to go by 1800 from this level. So I'll say edit, modify sub elements. I can actually get this and the entire line. When I click the entire line to move both points. So I'll say plus 1700 equal sign. Of course, I should have put 4000 at once. So this one will also be now complete. So you can see how I've been able to sketch the stair slab around the lift. So I'll select both floors. Okay, before I need to first adjust this line. I'll click on 1SA. I'll say copy to clipboard, paste selected levels, and paste it to a first and second. So by this, I have my stairs around the building. Of course, right now you're wondering why I'm having a slanting slab, but I'll explain later when we start the design. So my model is almost done. I'll click on Control save it, browse through a folder. I'll call it Office Building Structures Save. Yes. Now we are about to prepare our model for exporting now into Etabs. But before you export, we need to create what they call an analytical model. Now, what is an analytical model? An analytical model is like a 2D frame or a line drawing that represents center lines of structural elements such as beams and columns that can be used into that can be used by any analysis software to represent the physical beams and columns. So how do we do that? First of all, I'll open any elevation of my choice. Then I'll look at these beams and the columns. Now, at this point, we realize that my beams are actually in the right places, whereby if this is, let's say this is the second floor, the beam starts just on the second floor and drops downwards, which is a normal way. So this was achieved by setting. If I click on this beam, remember when I talked the geometric position, this one. You remember when I talked about the Z justification and the geometric position. So the correct way is that these beams are always supposed to be top. The Z justification should be top. However, for analysis purposes, we need to always first set these beams to be at center such that we are able to correctly export this model. Then later we'll take it back. So, because we need the center lines of an analytical model to be coinciding, like the center should be in position to meet. Like this, if I'm to assume the center of this beam is around here, this center here should be able to meet or intersect with the center or the top of this column at this joint. So to shift this beam such that its center is flashing with the center or the intersection of the levels, I'm going to select all the beams. Then I'll come to Z justification. I'll change it from top to center. But remember, this is temporary. We are going, after creating the analytical model, we shall need to take it back. So I'll also do the same for the ground beams. Click on one, press SA, change the Z justification to center. Similarly, ring beams, center. Here we go. So now we are ready to create the analytical model. So I'll come back to my 3D. I'll click on hide this scope box, even hide this. So here we have our model. Now, create the analytical model. We need to come to analyze, analytical automation. So give it a couple of seconds to load. So once it loads, here we have now two options. Option one is analytical to physical for buildings. So this is applicable when let's say you're importing from a structural design software such as Etabs. Now you want to create a physical model like in Etabs that can be used for detailing. Then option number two, this one, physical to analytical for buildings. This is used like for our instance, whereby when you have a physical model with beams, columns, physical columns and beams, and you want to create that line diagram or line drawing that can be used in other software such as Etabs, it's when you use the second option. So you guessed it right, we are going to use the second option. So click on it, let it run for a few seconds, about 5. So when it opens, it is just very simple to use. Click on select. It will tell you make a selection. Make sure you're in 3D. Highlight everything like this. Then don't bother about anything else. Just click on run. It's even telling you ready to run. So let it run also for about 10 seconds, depending on the size of your building. So it will tell you run complete. So just close it now. So an analytical model has been created. Now you may be wondering, where is the analytical model? So I'm first going to change this to hidden line. In fact, I'll change it to wireframe. Then I'll click on this. Not really. On this one, show analytical model. You see, when it is orange, there it is showing the analytical model. Now you can see these yellow or orange lines in the centers. So that is what we were fighting to achieve. Even the stair slab, also its analytical model has been created. If I'm to go to like an elevation, you can clearly now see how the analytical model is running. Maybe put it to wireframe. Yeah, you can now clearly see how the analytical model has been used. All right. Now I'm set, Control Self, come back to my 3D. I can turn it off, change back to hidden line or shaded. Now I need to export it to Etabs. Now to be able to export it, I'll come to adds in. Of course, you should have installed this CSI cross Revit extension, or sometimes you just go to to Google and look for CSI link. So come to your browser, let's say Google Chrome. Oh, it's taking long. Okay, Google Chrome, type in CSI, then CSI link Revit. Come to desktop. This CSI link, I think it is available for download at a free cost. So you can see the download option is just readily available. Let's see compatibility, font size, wish list. Oh, they're saying this is compatible with Revit 20, Revit 2021, 2017 to 2021. So meaning you might need to go and get the CSI now cross Revit from the Etabs website. If you type in CSI X Revit, twenty 25. Okay, depending on the version you have. So just come to this or this Revit trial and the CSI. So create an account, email address, submit. You get that free trial. If you like it, you can purchase it. Okay, let me go. Let's go back to Revit. So once you have the ads in the CSI Revit, it will give you these options under external tools, whereby you're able to create a new Etabs or SEF 2000 model, or you're able to export and update an existing SEF 2000 model. So normally for the new project, you're supposed to be using this. Then later on when we are updating, so when you use the second option, so I'll create a new model will show me that selected grids, analytical members, panels, and wall panels are going to be exported. So I'll say okay. I'll also say okay. It will give me an option to choose a location. I'll create a new folder. I will call it analysis. Now press enter, save. So this model now has been exported to Etabs. Fork has been exported, has been created, and it is ready for importing into Etabs. So now to import into Etabs, open any version of Etabs you have on your computer. For my case, I'm using Etabs 2022. So it will open. Or if you have SAP, it can also open in SAP because the company is the same. So when you're on Etabs, so you come to File, Import. Now, if you used the CSI link from Autodesk, you're supposed to come and you come to Etabs. Okay, you come to import Etabs E2K text file. That is when, or only if you use the CSI link from Autodesk. If you use the CSI course Revit from CSI or Computer Structures and Systems, you're supposed to come and use Revit structure. Now, for our sake, we use the CSI course Revit. So we are going to use Revit structure.exr file. So our browser location and analysis, it is here now. I'll click on open. So it will start opening. So I'll say okay. Save. All right, so guys, our model has been now imported into Etabs. So we are now ready to go. Here we have the plan views. Beside we have the 3D views. Of course, to orbit, you can press Shift, middle mouse button, or click on this icon here, rotate, and rotate freely. As you can see, this is the hollow cover we created. These are our slanting staircase slabs. So we really saved a lot of time. All we are left to do is modeling the exterior facade, analyze, model the trusses, create loads, load combinations, analyze, interpret results, design, export back to Revit, start the detailing. So guys, this marks the end of this first part of the design of an office building. Now in the next part, definitely we shall continue from putting slabs in Etabs, creating loads, load patterns, load combinations, modeling the steel presses and steel frames, designing, and so on as we move until this building is completely designed and detailed. Because actually, this is a real life project. So guys, please don't forget to subscribe, like and comment. Check out the files in the links provided for your own practice. Bye bye.